The construct understanding in 3.3 wants you to solve for x. Again, when it says solve, it means find out what x would be to make the equation true. So the first one starts out pretty easy. X squared equals 16. What do we do to solve a square? We unsquare it. We take the square root. So I would take the square root. I could write it like this, so I do the same thing to both sides. This becomes x, because x squared, square root, cancels out, it's just x. And the square root of 16 we know is 4. So that's easy. It's already simplified. Once I get to the point where I just have x on one side and a number on the other, done. Next one gives us x squared plus 5 equals 14. Well, that one is just one step more complicated, so all I really have to do is collect my like terms together on one side of the equation. So I'm going to send my plus 5 over here, and it's going to be a negative 5 when it goes over because I'm reversing the signs. I'm left with x squared equals 14 minus 5, and therefore x squared equals 9. Take the square root of each side, and x equals 3. To this one, now we have a few more numbers in the mix. So we want to try to keep it kind of along the same lines. We're just going to take the numbers to start with and collect them together. So this negative 8, whoops, that marker's no good. Guess we're using pink. This negative 8 has to come over here as positive 8 to start with. So we're going to be left with 2x squared on this side equals 16 plus 8 on this side. So we end up with 2x squared equals 16 plus 8 is 24. Now I have 2 times x squared equals 24. To get rid of the 2, the idea is to make x all by itself. I would divide by 2 on both sides, multiplying on this side, so divide on the other side, which cancels this out and leaves me with x squared equals 12. So that's not going to be a perfect answer. But if I take the square root of each one, then x just equals the square root of 12. Or you can plug the square root of 12 into your calculator and you'll get the answer that way. The other way to do it, and your book will prefer this one because it's the most accurate, is to make it into a mixed radical. So if I leave it like this, that's a true value. I'm not rounding off at all. If I were to put it in my calculator, knowing that it's not a perfect square root, I'm going to have to round that number off, and therefore I lose value. So your book doesn't like to do that. So what I do is look at it and go, okay, is this the simplest version? No, because 4 is a factor. Oh, that stuff's coming back. Woo. So I could rewrite this as the square root of 4 times 3, which means the square root of 4 is 2. It solves out into x actually becomes 2 root 3. So now it's done. The 3 got left under the root sign because it can't be solved, and the 4 did get solved, and now it's become 2. Now we've got brackets. So let's see. The easiest way to get rid of a square is to take the square root. We're trying to solve for x now, so if I were to actually FOIL this, I might be getting into territory where I'm getting more complicated stuff now. So what I can do instead, if I have a question like this, I'm going to take the square root of this side, which means I have to take the square root of that side as well. So if I take the square root of each of them, then I just have x minus 1 equals root 5. And that's okay, root 5 is a value. It's just we don't want to actually plug it into our calculators because once again we're going to have to round off the decimal and then we lose value. So we just leave it as root 5. X in this case is almost by itself already. All I have to do is move the 1 over. And then x is by itself. Then I have root 5 plus 1, because it's minus here, so root 5 plus 1. Or sometimes your book might decide to write 1 plus root 5. Either way, it's the same value. Remember, at the very end here, that root 5 might be a negative, right? It could be negative times a negative becoming that positive 5. So what we do is we just kind of modify this. We say it could be plus root 5 or it could be minus root 5. And that way we're kind of covering both bases in terms of whether or not this root is a negative or a positive.